Hey, Mary Faith.
Hi, Miss Sparks.
How are you?
I'm good. How are you?
Good, thank you. Do you have a particular question?
No, I do not.
Okay, you just want me to start kind of going over some of what we're learning?
Yeah.
Okay. I'm gonna hold on just 1 second. I want to share I'm gonna share the book, and I'm gonna share the a blank PDF
Okay.
too. Okay, this is kind of building on what we learned about in the functions and relations unit, and that's why I wanted to cover it first. We're talking about equations and two variables, which basically we've already discussed. That where there's an x and a y, and we've been working with the function tables and all of that, and we've also learned that f of x is really just kind of a fancy y. And we're going to be building on that whole concept. And so basically, it's what they're asking in this first question is this ordered pair, which one of the ordered pairs on example 1 is a solution to the 3x minus y equals 7? And so they started a test beginning with the letter A to see which one fit, and then they got to it by letter B. And so that's how they answered the example 1. So we're going to do the same thing with the guided practice A. And the problem is, or the equation rather, my favorite thing it's working right off the bat. Favorite. I really don't understand why there is technical difficulty. Always. I know, it's just. Okay, the first problem or the equation is x plus 2y equals 5. That's from the guided practice. For example, love you. Have a good day. Drive careful. I'm going to call the dentist. Sorry, guys. I'm going to call the dentist and tell him we're going to be running late.
Yeah, it's just 2:15.
Yeah, that I'm going to tell him. Love you. I'll text you about it. So what it's asking us is tell whether 4 and -1/2 is a solution to the problem. And so what you're going to do is plug in, this is just an ordered pair, and we're going to plug that in. So the 4 goes in for the x, and the -1/2 goes in for the y. And we're praising God about that because that 2 is a multiple of 2, obviously, so that's going to cancel. So this cancels and becomes a -1. So we have 4 plus -1 equals 5. And 4 plus -1 is what?
3.
3. And does 3 equal 5? No, it does not. So, oops. Oh my. Technical difficulties again. I couldn't be more thrilled. Like, what is that? Okay. So basically what we're seeing then is the graph does not, that would not be a solution. Does that make sense to you guys?
Yes.
Yes.
Okay. So is this kind of tying in? I mean, are you seeing this as a tie-in to what we did in the last unit?
Yeah.
Are y'all seeing the connection?
Yeah.
Mm-hmm.
Okay, good. So then let's move on through. Were any of these difficult for you guys? Or you just
I'm confused on number 2.
on the example 2 on guided practice?
Yeah.
Okay.
Not example 2, but the well, yeah, I guess is it example 2? Yeah.
Well, it would probably be the problem that refers back to example 2.
Oh, yes, yes.
Is that okay? Okay. So what I'm going to do then is take a look here.
Should we use graph paper for this?
I mean, I certainly would, because I don't like drawing my own graphs. I can barely draw the straight line. So I'm not going to challenge myself and draw the graph on top of it. That's just me. Some of you artists are much better at that stuff. You know, but I'm not going to put 2 challenges on my art abilities all at once. So yes, I would definitely use graph paper for this. Definitely. And this particular one, I'll share this on Google Classroom. This comes with 4 blank graphs, so you don't even really have to draw each individual one. But regular graph paper obviously is fine as well, you know.
Mm-hmm.
But I'll post this on Google Classroom if you guys want. So what we're going to do is go back to those X and Y tables that we were using. And oftentimes the book uses a horizontal one. Certainly not my favorite. I much prefer but in that last unit, she used a combination of both. Like even on the test yesterday, we had some horizontal tables. But my preference when I have the option to control it myself, I prefer a vertical one. So let's see, where is the guided practice there for this particular one? It's on page 155, correct?
Yes.
Mm-hmm.
Okay. So we have y equals, or y plus for number 2, we have y, well, it helps if you're, then y, this is number 2, guided practice number 2. Y plus 3x equals -2. So what I'm going to do is put in a table of values. And technically, I don't know how many points they use each time, but I really feel like 3 is enough, personally. So what I would do is do a -1, a 0, and a 1. You could do a -2, -1, 0, 1, and 2 if you wanted to, but really I'm fairly happy with 3 points on a line. So what you're going to do then is just like we did with the domain and range, you're going to plug in that -1 because x is your independent variable. So you can pick any x that you want to in this case, because in these cases, we're going to be dealing with a domain that really is all real numbers. So you can pick anything on a linear equation. So I'm picking -1, 0, and 1. So if I plug in a -1 into my equation up here, I've got y plus, and 3 times -1 is -3 equals -2. So I'm going to add 3 to both sides because I'm solving for the letter y at this point. And I have y equals, and then -2 plus 3 is a positive 1. So where x is negative 1, y is 1. And now I'm going to plug in y plus, and then we've got 3 times 0 equals negative 2. And y plus 3 times 0 is 0 equals negative 2. And so y equals negative 2. So where x is 0, y is negative 2. And then my last one, y plus 3 times 1 equals negative 2. Y plus 3 equals negative 2. Subtract 3 from both sides, and I have y equals negative 5. So now I'm going to go back and plot these points. So negative 1, 1. So I go left 1, up 1. And then I have 0, negative 2. So I'm going to stay on the y-axis and just go down 2. And then 1, and then 1, 2, 3, 4, 5. And then I'm going to connect my dots. Oh, wow. That's really bad. Can y'all see that flashing, or is it just me?
I see it.
I see it.
So then I connect my dots and I have my line. Man, that's crazy. All that craziness there. I'm going to erase my work, but I'll keep the XY table up. Is everybody understanding where I get those values? Are there any questions about that? Did that clarify it a little bit for you, Mary Faith?
Yes.
Yes.
Okay. So you can pick any values that you want to go in that XY table. And I just say pick things that are easy for you to substitute. And once again, when we have a fraction, you always want to pick numbers that are multiples of the denominator, if that is the case.
Could we do number 5 and 3.2?
Oh, yes. On the guided practice or in the
in the textbook?
In the actual. Oh, yes, absolutely. Do you care if I do the guided practice for 3 and 4 first?
Oh, no,
and
not
then,
at all.
Not at all.
Okay, and then I'll do that. Thank you so much for asking the question, though, and I will absolutely do it. I just wanted to make a point about the fact that y is going to be the number 3, y equals 2.5. Y equals 2.5 is going to be a horizontal line, because y is basically going to be 2.5 no matter what the x is. If x was 0, it's going to be 2.5. If x was 1, it's going to be 2.5. So, the challenge will be for Mrs. Sparks to draw a line a horizontal line at 2.5. Whoops. So that's going to be a horizontal line, and number 4 is going to be a vertical line. Or yes, example number 4. Because no matter what y is, x is going to be negative 4. So 1, 2, 3, 4. So, and it's kind of interesting, because we just got done working with zeros of a function, and we discovered that the zeros of the function can be x equals and then something. That's a very different animal than these than the vertical line equation. But in a problem, it will actually state this is a vertical line or this is a 0. So you have to definitely watch the syntax when working with graphs. It's big. Vocabulary is a very important part of math, as much as it is English sometimes. The big difference for example 4 is when they're limiting the domain. And I want to talk about that just briefly. And then we're going to move forward. When they're limiting the domain, remember how when I started this particular lesson, when they don't limit, when they're not limiting the domain, I told you guys that you could pick any X that you wanted to put in your tables, right? Anything that you wanted to. But when the problem states that there's a limit on the domain, as there is in example 4, it says that it only wants you to plug in values of X that are greater than or equal to 0. So that's all that you'll use. So that means that there's going to be a limit to it, and there's going to be a stopping point. So let's take a look at number 5. Graph the function y equals negative 3x plus 1 with a domain of x is less than or equal to 0. So that means I'm never going to pick any integer or real number, irrational number that's greater than 0. So everything has to be 0 and below. So what that means for number 5, it's asking us to graph the function y equals negative 3x plus 1. But the domain has to be numbers that are less than 0. So can I use the number 1 for my solution? For my x, can I use the number 1?
No.
Anybody know?
No.
No.
No, you cannot use it because it is greater than 0. And let me point that out in the book.
Wait, what?
You see down here at the bottom, Mary Grace, for guided practice, where it says, and I can't write because this is a book, but graph the function y equals negative 3x plus 1 with the domain x is less than or equal to 0. Do you see that problem? Yeah. Okay. You're supposed to identify the range of the function after we get done. But what it's saying is, remember earlier when I said a linear equation, you can pick any x's that you want to in your table? And I said normally pick like negative 1, 0, and 1 because those are easy to work with.
Yeah.
Remember? Yeah. Okay. Well, this one is stating you can't pick certain ones. It's saying there is a very specific domain. And it's saying that it only wants you to pick numbers that are less than or equal to 0 for your X and Y table. So I asked the question, can I pick the number 1 for my XY table? For number 5. I cannot because it's limiting my domain. Because it says that all numbers need to be less than or equal to 0. It's got a domain of that. Okay? So I can't pick the number 1. I can pick 0, and I can pick negative 1, and I can pick negative 2. So now what I'll do is plug those in. If I pick 0, that's going to give me a 0. Whoops. So y equals 0. No, y equals 1. My apologies. So when x is 0, y is 1. And now I can put in a negative 1. So negative 3 times negative 1 is a positive 3. And 3 plus 1 is 4. So when x is negative 1, y is 4.
Okay.
when x is -2, -3 times -2 is a +6 plus 1, y equals 7. So when x is -2, y is 7. So now I'm going to plot those points, 0, 1, -1 and 4, 1, 2, 3, 4, and -2 and 7, 1, 2, 3, 4, 6, 7. Now there's an interesting thing about this line. Because the domain is less than or equal to 0, remember how in the last unit, sometimes we would have one of those blocks and the arrow would only go in one direction.
Mm-hmm.
So your domain was x than or less than 0. Remember that?
Yeah.
Well, you've created that when you, in this problem, when they limited the domain. So then it's asking us, the final question is identify the range. So the y is actually going to be, my lowest point is right here. So y, my range is going to be y is greater than or equal to 1. So it asked us a couple things. It said to graph the function with a domain of x less than or equal to 0, and then identify the range. So the first thing that we learned is that when they limit the domain out of the gate, you have to make sure that your x and y table includes only the values that fit within that domain, which we did. That was 0, -1, -2. We discussed the fact that anything greater than 0, we can't even put that in our XY table. Then we plugged in a few values. 3 usually is a good one for a line. We plugged in those values and we determined what those were. And then we figured out that once we graph it, our graph is actually going to have an arrow only on one end because it's only going to continue in one direction because there is a limited domain, thereby limiting the range as well. Does that make sense? Sort of?
Yes, ma'am.
Yes.
Yes, ma'am.
Okay, good. Oh, how many people are with me?
4.
4. Okay. So I have Mary, Addison, Eli. It looked like Stephen came on, but he left me. Okay. All right. Now the next question that I had came from the textbook work. I believe it was number 5 from the textbook. Okay, great one to ask a question on. Great question. Okay, the problem is x equals 9. Tell whether the ordered pair is a solution of the equation. And the ordered pair is 9 and 6. And the only thing you want to do when it's a horizontal or vertical line, and this is actually a vertical line, which says the y can be anything in the whole wide world. I'm going to graph it just so that you can visually see this one, but we're going to talk about, we're going to go ahead and talk about it a little bit more to make sure that we, that we get it. Because I think I'm going to go over number 6 too. No, it wasn't assigned, but I want to talk about it. That's a horizontal line and it has kind of the same idea to it. So what we were used to doing in like number 3 is you were just actually plugging in the ordered pair to find out if the solution was true. But on number 5, and you could kind of do the same thing, x equals 9, and the ordered pair is 9 and 6. The only thing you need to make sure on this is, does x equal 9 in this ordered pair? That's what you're kind of asking. And it does. But just to, let's see, I think it would be way over here. This is actually going to be a vertical line all the way over here, believe it or not. And so 9, where would the 6 be? Let's see, 1, 2, 3, 4, 5, 6. So 9, 6 would be about right here. So it actually does fit on the line. But the quick way to do it is, if x equals 9, you want to make sure this is a coordinate. But if it were vice versa, if it were 6, 9, it would not be a solution because the x is a 6. Does that make sense?
Yeah.
Kind of.
Okay. So let's look at number 6 in the textbook very quickly. It says y equals -7, and it gives the ordered pair -7, 0. But it tells us the y has to equal -7. Does the y equal -7 in that ordered pair?
No.
No. The x equals the -7. So for number 6, that ordered pair would not be a solution. But number 5, it is a solution. Can anybody tell me what's wrong with number 9? The error analysis.
It is a solution.
It is describe and correct the error and determine whether 811 is a solution.
They put x. Put 8 as the x instead of the y. Or sorry, they put the 8 as a y.
Yes. He put the 8 as the y and the x as that. So it is not a solution. So you guys explained it very well. So 811 is not a solution, because if you plugged it in correctly, you should be plugging it in as 11 minus 8.
How do you do 11 through 22?
11 through 22, graphing the equation. Those are the ones where you have to make those X, Y tables. So let's take a look at those. Once again, it goes along with example 2 from the guided practice, I believe. Wasn't that the one where we were doing X, Y tables? Is that right? Am I referring to the right example? So, so on those, number 11, let's do it first. You have y plus x equals 2. So we're going to do this 11 through 22 don't have a limited domains. We kind of get that into that in the later in the later part of the, oh my. Of the homework. So we can pick any x's that we want to in this XY table. In any of them, because the domain is not limited. And so we can pick, and most of the time what I do just to make the math simple is I pick -1, 0, and 1, except for when there is a fraction being multiplied by the x. And then I use a multiple of the fraction in order to clear it. So here I'm just going to plug in a -1 into my equation and then solve for y.
I thought when you graphed equations, you had to get the y by itself.
Very interesting. Yes, we are going to learn that way too. This is just another way. There are multiple ways to graph equations. That's a great question. Thank you so much for bringing that out. That is when we deal with the slope intercept, which is 90% of the time how you're going to do it.
Oh.
But it's very important that you learn how to use an XY table too. It's also important to learn that that these, you know, like we learned in the last unit, that these are functions and ordered pairs. And the results of a function are all ordered pairs. So this is just another way. The next way we're going to learn how to graph an equation is by using the X and the Y intercepts. So there's multiple ways to graph. This is just another example. Thank you so much for asking. Y'all asked such great questions. I'm so proud of you guys.
Miss Sparks, did you already do number 5?
Yes, ma'am. I did.
Could you redo it? I still don't understand.
Yes, I can. Let me finish this one and then I'll go back to that one.
Okay.
Let's see. So now I have y equals 3. So the ordered pair for the x, for when x is a -1, the answer is 3. All right, so then I'm going to plug in my 0. So I have y plus 0 equals 2. So y equals 2. So when x is 0, y is 2. And then the last one, I have y plus 1 equals 2. Subtract 1 from both sides, and I have y equals 1. So when x is 1, y is 1. So now I'm going to graph these 3 ordered pairs. I'll go over 1, up 3. I'll go over none, up 2. I'll go over 1, up 1. Well, and then you're supposed to get a straight line. When Miss Sparks draws it, it isn't always that. But anyway, so basically this is another way to graph an equation by using an XY table and plugging in values. So that's what we've done there. I should have actually written my XY table down underneath it. I think
So
I'm going
you
to do
can
that
just
now.
plug in NAX.
Yes, unless they're limiting the domain, which they start doing that in question number 27. And then you have to pick only the values within the domain that they give you. Does that make sense?
Yes.
And I'm telling you guys, 3 is plenty. Really, you can do 2, but just to make sure you're drawing a good line and to kind of get in the habit, because later on when we do quadratic equations, you really need 3. I kind of stick with the idea of 3, but when we get to the x and y intercepts, I really think you're only going to use 2 on a linear equation. But there are so many ways. We're gonna learn to find the slope. We're gonna learn to get y by itself. So many different ways. This is just another way by using the XY table. Okay, Mary Faith, number 5. It says x equals 9. And then it gives the ordered pair 9 and 6. Remember how I talked about from the guided practice that an x equals 9, like 9, or x equals 4. I can't remember what the guided practice example was exactly. I think it was -4. It's a vertical line. Do you remember that part?
Yeah.
Okay. So that means this is going to be a vertical line at the point of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's all the way over here. Huh?
Do we have to graph this?
No, I'm just showing you why it's true. So if I go over 9 and up 6, it's going to be, well, actually it would be up here. It'd be about right here. So it is a solution, isn't it? It's on that line, correct? If you graphed it, you could see that it was a solution, right?
Yeah.
Okay. If you look at the ordered pair, does x equal 9? What is the x in the ordered pair?
Yeah, it is 9.
Okay. So it's true. It is a solution. Does that make sense?
Yeah.
Okay, but look at number 6 in your book. This was because I was trying to make sure that you guys saw the difference. You see where it says y equals -7? And then it gives the ordered pair -7, 0. Do you see that?
Yeah.
Would that be a solution?
No.
Right, because y doesn't equal -7. Good job. Does that make sense to you?
Yeah, that makes sense, sir.
Okay, great. All right. Does anybody want me to do number 13 as another example for 11 through 22?
Could you do number 17?
I would be happy to do number 17.
Thank you.
I'm going to do number 17. And it is x minus 2y equals 3. Okay, so I'm going to do my xy table down here this time. Okay, so once again, I'm going to use my favorite numbers of -1, 0, and 1. And so I'm going to plug in a -1 for my x minus 2y equals 3. So I'm going to add 1 to both sides because I'm just going to use my principles of algebra that I know now, that we've worked on, and we love them so much. So I have 3 plus 1. That's going to be 4. I'm going to divide both sides by -2, and that's going to give me y equals -2. So when x is a -1, y is -2. And now I'm going to plug in a 0. For my x. And I have -2y equals 3. Divide both sides by -2. And I have y equals -3/2. Certainly always my favorite thing to do is graph fractions. That's basically right around -1.5. So not too big of a deal. And then I'm going to graph 1. I didn't really need to erase everything, but I did. But I have 1 minus 2y equals 3. Subtract 1 from both sides. And I have -2y equals 2. Divide both sides by -2. And y equals -1. So when x is 1, y is -1. Now, I'm going to graph -1, -2. So I go left 1, down 2. And I'm going to graph 0, -3/2, which is roughly 1.5. So I'm going to not move at all on the y-axis, and I'm going to go down about 1.5. And then I'm going to go over 1, down 1. Over to the right 1, and then down 1. Connect my dots. And I have my line for number 17. Y'all were supposed to work through what?
23.
3 through 27 odd?
27, yeah, you're right.
So there was really only one question that limited the domain. Is that correct?
Yes, ma'am.
Okay. So I'm going to actually do that one with you guys to explain that, just because it's a little different, you know. because you're limiting that domain. Did everybody get number 17 written down? May I erase it? How about if I leave up the XY table and just erase my work that's down here? Okay. Number 27 says, y equals negative 5x plus 3. But the domain has to be numbers that are less than or equal to 0, much like our example. So does that mean I can pick the numbers 1 or 2 or 3 or 4? If they limited my domain to all numbers less than 0, is 1 a possibility, or 2 or 3?
No.
No, ma'am.
No. That's right. It's not. Good job, guys. It is not a possibility. I have to pick numbers that are less than or equal to 0. So I'm definitely going to pick 0 because that's just easy to work with. And then I'm going to pick a negative 1, another good one to work with. And then I guess I'll do negative 2, but I doubt very seriously I can even graph that one because I'm seeing it to be a rather big number in my head. No, I mean, it's not a huge number, but not graphable on these little graphs. But if I stick in a 0 there, if I stick in a 0 to that equation, I'm going to have, I got to go ahead and erase my XY table at this point because I need this area to work. I have y equals negative 5 times 0 plus 3. So that gives me 0 plus 3. So y equals 3. So when x is 0, y is 3. When x is negative 1, negative 5 times negative 1 is a positive 5, and 5 plus 3 is 8. So when x is negative 1, y is 8. When x is negative 2, negative 5 times negative 2 is a positive 10, and 10 plus 3 is 13. So I have 0, 3. I have negative 1, 8. That's going to be way up here. 1, 2, 3, 4, 5, 6, 7, 8. Yep. And then I have negative 2, 13. And that's going to be way up here. So remember, right here is where my line is going to start because my domain is x is less than 0. My range, and you actually, in all honesty, could have made these go by 2. I just didn't want to confuse y'all in math lab, and it probably, if I would have done that, it would have made them, or even go by 3s, it would have made everything kind of fit on there. You could have, done your y-axis a little differently, like by 2s or whatever. But the most important thing is to realize that because we've limited the domain, our range is also going to be limited. And this is the lowest point. So y is going to be greater than or equal to 3. That's the range. Does that make sense to you guys?
Yes, ma'am.
Yeah.
Okay. That was the last one that you had to do for the homework. That was the only one out of those that you really had to do.
Could you do number 19?
Absolutely. And just kind of taking a survey, is a morning math lab better for you guys?
Yes.
Okay.
Yes, ma'am.
I'm going to try to I'm sorry?
Yes,
Eli, you
ma'am.
said yes, ma'am? Oh, okay, good. Well, I'm going to try to keep it consistently at 9:30 for the rest of the year then. Because it seems like it is a little better. All right, number 19, x equals 0. This is a funny one because this means that x is going to be 0 every time y is anything. It doesn't make any difference what y is, x is going to be 0. So that is literally the y-axis. Because would you agree with me that x is 0 on all those places, no matter what y is?
Yes.
So that's kind of, and the same, like if you look at number 20, that's the x-axis. Y equals 0 is actually the x-axis. I know that one's one of those like, wow, am I even looking at that right?
Could you do
19, 21?
Yes, ma'am.
I sure can. Do you care if I do it on that same graph? Because it's kind of almost the same thing.
That's fine.
Y equals -4. So, oops, that's a funky looking 4. So y equals -4. That means no matter what my x is, y is always going to be -4. So that's going to be 1, 2, 3, 4. That is a horizontal line. Pretty. Which mine looks a little vertical, even though I tried very hard to make it straight. That's a horizontal line that runs through -4, because that means no matter what my x is, my x could be 2, my x could be -2, it could be -5, -6, but y is always going to be -4. It never changes. So it is a horizontal line. An x equals is always a vertical line, and a y equals is always a horizontal line.
Ask her about, do we need to graph each of these and just double check it?
Do we need to graph each one of these?
On 11 through the odds 11 through 27. Well, 11 through 21, you have to graph those, and number 27, you have to graph that one. Number 23 and 25, you just have to identify which graph goes with that. But yes, 11 through 27, 11 through 21, yes, you have to graph. And number 27, you have to graph. So I think 1, 2, 3, 4, 5, 6, 7 graphs you should have in total. And you're using the XY tables to determine what your ordered pairs are.
So you would graph 21?
Yes. Just like I did right there.
Oh, okay. I didn't see it.
Yeah. Number 19 and number 21 are on the same graph. The vertical line is the x equals 0 because I kind of drew over the y-axis. And then number 21 is the horizontal line that falls in the lower quadrants of the coordinate plane. I probably should have done it in a different color. That would have helped. Any other questions over the guided practice or the assigned problems or anything in this lesson? Anything you don't understand? We will talk about it in class tomorrow. But is there anything you don't understand? Have y'all had an opportunity to watch the video yet?
Yes, ma'am.
No.
Okay.
Now.
It is a longer video, but he goes through a lot of the examples that I did. And my hope is that it's going to continue bringing the concepts that we just went over in the last unit into this unit. We're going to be doing a good bit of graphing for the remainder of the year. So you definitely need to bring graph paper. But that's kind of what our focus is, and learning that these linear equations sometimes are called linear functions and that kind of thing. So vocabulary is kind of intense because these are probably some words in math that you're not as familiar with. And so just trying to identify what these things are and clarifying that. That's what we're going to be doing.
Thank you.
And like I say, but I just thought the explanation was clear and there was a lot of examples, and I feel like that will really help. Most of the time, I really do try very hard to keep them 10 minutes and under. Because I know y'all have other things you need to do. But if you have any more questions for the remainder of the day, please email me and let me know. And I appreciate y'all coming to Math Lab. Any other questions?
No, ma'am.
No, ma'am.
Okay. All right. You guys have a blessed day.
You too. Thank you.
Bye-bye.
Bye.
Bye.
Bye.